have a lot of worksheets. We may have a lot of text-heavy learning components. We also could have a lot of video components. One of my things I do as a flipped learning teacher is I create short videos, 3, 5, 7 minutes, of any given topic that I want students to be able to learn, know, or do. And with that, I combine them and they become the source of my DIBS. But I also have some experimentation that I do. We take the little cars that you pull back and you let go, and they run down the road. And we do some timings and we collect some real life data. But if the student isn't available, or whatever reason, we have an assembly, we have whatever that causes us to not be able to do that, I still have a video version of students doing that process. And the information that students need, whether they're there or not, or we're able to participate in person or not, to do the learning that I need them to do, regardless of their location or attendance. So that's one of the things for math that I can put together and put into a DIB. Now, the other thing that we can do is for science. I love the use of DIBS for science because it takes forever to put together an experiment. It takes forever to get out all the pieces and the components and to set up the various stations. And science teachers, you guys work really, really hard on this. But if a student isn't there, or if a student can't get to all the stations at the right time, or if we're missing some components, or we allow a student choice of which ones they wish to do in person and which ones they might wish to do digitally, there's a variety of reasons we might want to have those experiments done in a set of DIBs. Now, there's two things that we could kind of accomplish here. Number one, we could go through the instructions of whatever this scientific setup is, and we can say you do this to this and this, and this is how many milliliters, etc., that go into this. Now that you know how to do it, I want you to go and do it. And what we've just done is we've saved a whole bunch of class time and replicated ourselves from having to do this over and over through the course of the day for every station or every group of students. The students can see us do this, which we want to be consistent, eminently and infinitely consistent every time. We want them to do it right. Then let's just do it once and make sure it's right, and they can all see it when they need it and can refer back to it if they need it again. So instructions are great in a science class. Now, just like our art example, we really want to go to an art museum to see the art. But if I can't get there, I still want to be able to access it online. In the same way, I want students to do the experiment because there's something about the hands-on, the reality, and the application that's important. But for whatever reason, we know that not every student gets in our classroom and gets those things accomplished. So if we have an experiment that we can do, we can run it, or better yet, have students run it for other students and video it. Because this is another way for peers to be teaching peers. And as the teacher, you're just facilitating. And if a set of students is doing the presentation for another set of students, that's a whole level of responsibility that we absolutely want students taking. We absolutely want students to take at a level of seriousness. Why must we always be the ones that have the fun? So you can do the experiment and videotape it, archive it, curate it, and put it in a DIB so that students can access it as they need. Again, it allows more experimentation, more stations, etc. Also for you science guys, I have a great friend in New Jersey that loves science, mainly because it involves fire and danger. And some of his experiments he gets to do in front of the classroom, and it's great to see live. But at some point he's going to burn his eyebrows off. And that's okay for him. But we don't necessarily want students present when we do that. So some of those experiments that need to be in a more controlled space, that need to be in a safer space, are also things that we can do digitally. And that's something that we can provide to students, or we can go different places and do experiments or take original documentation and then share it with students. So science, DIBS are right up your alley. The ideals of the flipped classroom, even if you don't want to do a full flip, these ideas can really be put to use in your classroom.